Welcome back. Let's learn how to build our own graph. Graphs, when you look at them, look very intimidating. But here's the thing. We've actually learned the tools necessary to build graphs, because graphs are built on top of other data structures. Remember this diagram of the directed acyclic graph? Well, many of the data structures that we've been playing with up until now can create something like this, using trees and linked lists. I mean, it looks pretty similar, right? You have a node with children and different pointers. Using that knowledge, let's talk about how to start thinking about graphs, or at least how to think about building them. There's 3 ways that you can think about it. The first is called an edge list. And I have an example for you that we can use to build something like this. Let's say we want to build this graph. How would we go about doing this? With an edge list, we can say const graph equals to something like this. Now let's see what I did here. I have an array, and within this array I have 1, 2, 3, 4 items that itself they are arrays. But if we look at the graph, the array simply states the connections. That is, we have 0 and 2 as the first item in the array. We have 2 and 3 as the second array inside of the array. And then 2 and 1 and 1 and 3. An edge list simply shows the connection, that 0 is connected to 2 and 2 is connected to 0. 2 is connected to 3, 3 is connected to 2, 2 to 1, 1 to 3, so on and so forth. Quite simple. There's another way called adjacency or adjacent list. And in this case, we can create a graph where the index is the node and the value is the node's neighbors. What do I mean by that? Well, in here, we can use arrays, we can use objects, we can use linked lists. But let's say that in the index of 0, the first item, 0 is connected to 2. The index of 1, that is node 1, is connected to 2 and 3. Index of 2 is connected to 0, 1, and 3. And then finally, index of 3, or node 3, is connected to 1 and 2. And you can also do the above with an object, where it might even be clearer. And if a node value is something other than a number, you can actually give it a value, so a key and a value. And this is extremely useful with object if you have, like I said, not a sequential number as we do in this example. And when we implement our own graph, we're going to use an adjacent list using an object, and you'll see what I mean. Finally, I want to show you the last method to represent graphs. It's called adjacent matrix. And an adjacent matrix is going to look something like this. This matrix is simply going to have zeros and ones indicating whether the node X has a connection to node Y. 0 means no, 1 means yes. And if you have a weighted graph, you can actually add weights here instead of 1 and 0, so they can actually be numbers. I'm not going to type this out because I'm going to bore you to death, but here is the same representation that we've done with edge list and adjacent list, this time with adjacent matrix. What does it mean? Well, index of 0 has connection with 0, 1, 2. So 0 is connected to 2. Then node 1 is connected to 2 and 3. Node 2 is connected to 0, 1, and 3. And you can see how it's very similar to here. And node 4 is connected to 1 and 2, just like over here. And once again, instead of arrays, you can use objects here and actually give it a key and a value. So that this, if it was an object, would be 0, 1, 2, and 3. And if we go to Visual Go, you'll actually see that they have these 3 ways to describe graphs. The adjacency matrix, and because it's weighted, you see that there's numbers here instead of 0 and 1. We have the adjacency list, where it looks like here they have a hash table with the values, and also an edge list with an extra property of the weights because this is a weighted graph. And you can see the weights as well in the adjacency list. But we've just taken a look at a lot of numbers. I think it's time for us to build our own graph to finalize our understanding. I'll see you in the next one. Bye-bye.